So, our carnival barker, to feel like a human being in what can be a trying job, would at least like to have a name by which they can be referred to, to which they can be referred. To which? What? Whatever. Add this to their interface implementation as a property. All right, step one. Raise your hand if you were able to add a property. Sam, let's add a property. Yep. Neat. Sorry? Ooh. Like that. Cool. Interesting. So this creates a property that's an NS string called name. What is this? What is this copy thing? Yeah, we're going to get into this when we talk about accessors, when we talk about atomic properties. There are a whole bunch of ways, similar to us using the keyword weak or private. There are a whole bunch of ways that our properties get stored, and also the way that they get compiled from our interface into an actual program for us. So this copy, specifically, copy is telling our compiler that when we modify this object, because that's an NS string, it shouldn't overwrite the original location, but instead save to a new one. Sort of similar to using a struct. Neat. All right, we got a property.
Is that what we want for this property?
I do. It makes a difference in some cases. Think about how references work. We'll do a little bit more with it next time. But we'll build more and more classes, more instances, and see exactly why that goes that way. But I want to just add this property for now. Sam, let's keep going. That was my interface. How do I get that into my implementation? At synthesize. Interesting. At synthesize. What's that?
Would this name like the name of the class carnival barker?
No, it wouldn't do that. So this underscore name is something that we're not creating ourselves. It comes from what the interface, what the implementation creates internally for itself when it sees the property, kind of like a private variable called an IVAR, or an instance variable. So when we create, isn't this awesome? All this internal stuff. When we create a property, we'll get this to work in a second, it doesn't actually get stored on the instance as just that property, but instead it creates an internal variable, an instance variable, with this underscore characteristic that is only allowed to be used within the scope of that instance. So it's kind of like creating a private var for us to use with our properties. And this goes back to our encapsulation principle. If I only want to use a private var in the context where I need it, but I don't want to expose it to someone else, it's not going to be in my interface. We only want someone to use the interface in the ways that we are defining to them. So there might be a property called name that someone else can use, but our instance variables are different. Properties and ivars are not the same thing. You can think of them like public and private variables. You're going to learn more about how this synthesize works. There's so much fun stuff to do with classes. Don't you love it?
Order.
What?
Order.
Order?
And typically when we create structured classes, we just, to be clear, put properties and methods. And now you're going to look.
I am.
That's on purpose.
That's how I like to do it. I'll get you a better answer next time. It doesn't have quite the same style guide that we're used to with Swift. Sunny?
Can you explain the difference between synthesize and dynamic?
We don't need dynamic right now, but synthesize by itself, what it means is that if we have a property called this thing called name, we actually don't really even need synthesize anymore. This is like an older paradigm. If we have a property, we can tell the compiler that we want to make it available in certain ways. So let's go back to our header file. There are other options we could put in this like parens here. We could say this is read-only. We could say it's read-write, which is actually the default. But a property, by default, it's read and write, which in Swift terms, if this was a computed property, what would the keywords for read and write be? Get and set. Like get set. And so when the property called name is synthesized, it's out of the box or using the synthesize, it automatically creates two messages that we can send to an instance. The getter is always the name of that property. Here, that's name. And the setter, by default, is set name, or set name of property. Here, set name. So synthesize is creating for us the accessors, the get set for our property. So if I call set name on this property name, it's going to change it. But Sam said, let's include the option to copy it. It's not going to change the original reference to that name. Instead, it's going to allocate some new space to it. There's so much to go into with properties. It's going to be great. Objective-C rules. We all love it, right? Okay. So when we talk about synthesizing, a property gets, by default, its accessors, which are read and write, synthesized to it. So let's make sure our implementation is correct. Sam, is that all you did in your implementation? Okay. What? Okay. Let's see if this works. Carnival Barker. Blah, blah, blah. Bad Barker. Let's see if we can send it a message, because we should have a getter and a setter if this property is working. Set name. So this void function is synthesized to us, for us, I'm sorry, by virtue of having that property. The value of that property goes down to that ivar, which we'll talk about more, and don't worry. But just by having a property, we have the accessors, we have the get set, we have the read write for that property. We don't have to create a function called set name. That is what is actually synthesized. That's what we're talking about when we say synthesize our property or synthesize this thing called name. Which means that I said Bad Barker is named a dog dressed as a man. Then, if I went to log that out, the employee I see is, Liana, what's the formatter for if I wanted to just print out the name of this Bad Barker? Okay. It's not going to be F. Let's go look at the property. Okay. It's going to be an @ sign. So for any object, to print out an object, which name is an NS string, I use that @ sign as the formatter or the token or whatever fun thing you want to call it. Now here, again, just by virtue of synthesizing that property, I can see that the employee here is a dog dressed as a man. So these two accessors get set for us. You can override them, you can do a whole bunch of stuff. Sam?
Do you need the close brackets and that
Which line? Sorry? Do I need these like that? What else could I do? I can use dot notation for a very specific reason. Yep. For the synthesized accessors of a property, I can use dot notation. I can also send a message like we're used to. Where's Albert? Cool. That's as far as I want to go for today. With properties, we're going to talk more about that whole synthesizing thing. We're going to talk about the different kinds of properties, how that affects inheritance and polymorphism. We're going to just keep doing a little more practice with our classes, do multiple inheritance, do stuff like that. And that's the fun stuff. What are some questions you have before we break? What? Oh, yes, there will be a lab later today that I'd ask you to do by Monday. Yes, thank you for asking that. Coat rack. Cool.